A warm welcome to you, dear students. I am teacher Sharon De Silva, and in this video we will learn about properties of natural resources. Natural resources. Now, what exactly are natural resources? Natural resources are resources that exist without any actions of humankind. On Earth, it includes sunlight, atmosphere, water, land, which includes all minerals, along with all vegetation, crops, and animal life. We are going to study about properties of a few of these natural resources, namely air, water, and soil. The first one what we are going to discuss is air. Air is all around us. We cannot see it, yet we feel the presence of air. When we inhale, air is taken in through the nose. If we blow on our hand through our lips, we can feel the air. Now we are going to discuss about properties of air. Now these properties we are going to discuss on the basis of some activities. But there is no need to perform these activities at home. First property, air has weight. Now we have to take a stick and tie a thread at its center and hang it so that it remains horizontal. Something like this. Tie two rubber balloons of the same size at the two ends of the stick. Check the position of the stick, it is horizontal. Deflate one balloon means remove the air from one balloon. Check the position of the deflated balloon. It will look something like this. The stick goes up on the side of the deflated balloon. This means that the inflated side is heavier. That means the side on which balloon which has air inside is heavier. So this heaviness is because of the air which is inside the balloon, telling us that air has weight. Now, air is a mixture of gases, therefore, like all other matter, it has mass and weight. The next property is atmospheric pressure is the same in all the directions. We have to take an injection syringe without the needle. Pull its piston and observe it as you do so. The piston can be pulled out easily. The piston then remains in that position even if you let it go. Now close the inlet hole of the syringe tightly with your thumb. Pull the piston and let it go. So something like this. The molecules of the gases in the air are in constant motion. When these molecules strike a body, they create pressure on that body. This is the pressure of air that we call atmospheric pressure. On pulling the piston with the inlet hole of the syringe closed, more space becomes available to the air in the syringe and it becomes rarefied, means of low pressure than usual. As a result, the pressure of the air in the syringe is lowered. Comparatively, the pressure of the air outside is very high. When the pulled out piston is released, it is immediately pushed in. If the experiment is repeated holding the syringe at different positions like vertical, horizontal or inclined, the piston is found to go in the same go in to the same extent in all the cases. From this, we can infer that atmospheric pressure is the same in all directions. Now, this particular activity, my dear students, is a fun activity. You can do it at home, but has to be done in the presence of an adult. Now, what is this? Place a piece of cardboard on the mouth of a glass filled completely with water. Holding the cardboard firmly in place, with one hand, invert the glass quickly. Take your hand away from the cardboard. What do you see? It's a fun activity. You can do it whenever you want in the presence of an adult. Now in 1726, the Swedish scientist Daniel Bernoulli put forth the important principle that the presence of air decreases when its velocity increases, while the pressure of air increases when its velocity decreases. Here is his picture. If a body is moving through air, the air pressure decreases perpendicular to the direction of the motion, and the air in its surroundings flow rapidly from higher pressure to the lower pressure. This is just for your information. You will study about him in higher classes. Now, effect of air pressure. Take some water in a plastic cup and hold a straw upright in it. Hold a small piece of another straw near the upper end of the first straw and perpendicular to that of the straw. Blow hard through the small piece of straw. You will see a fountain of water. Something like this. I'll repeat, take some water in a plastic cup and hold a straw upright in it. Hold a small piece of another straw near the upper end of the first straw and perpendicular to that of the straw. Blow hard through the small piece of straw. You will see a fountain of water. Why did this happen? On blowing through the straw, the air at its open end is pushed away, and hence the pressure of the air at the opening goes down. As the pressure of the air near the upper end of the erect straw becomes less than the atmospheric pressure, the water in the cup is pushed from where the pressure is higher to where it is lower, that is in the upward direction, and the water comes out in the form of a fountain. So what happens when you blow air from here? Air pressure over here goes down and water rushes in and water comes out because air pressure inside the straw is lowered. So water comes out in the form of a fountain. The more forcefully you blow, the higher will be the fountain. This straw fountain works on Bernoulli's principle. Now, the effect of increased temperature on the pressure of air. When there exists a difference in the air pressure at two different places, the air starts flowing from the place of higher pressure to the place of lower pressure. At such times, we feel a breeze or a wind blowing. Thus, winds are an effect of the difference in air pressure. So, what is the effect of increased temperature on the pressure of air? I'll repeat. When there exists a difference in the air pressure at two different places, the air starts flowing from the place of higher pressure to the lower pressure. And that is how we feel breeze. So this is what happens during the daytime. Because of the sun, the hot air rises up. And what happens is low pressure is created over here on land. So, and sea is cooled down. So hot air rises up and goes towards the sea, and the temperature is over here is lesser compared to the land. So high pressure zone is created over here, and because low pressure is over here, this high pressure zone, the air from the sea goes towards the land, and this is like a continuous cycle. You'll study more about this in higher classes in geography. So this is how breeze is created. So this happens during daytime, and the reverse happens during night time. What happens is during the day the land is also heated up and water is also heated up, but compared to land, water is less heated. Land cools down easily when the sun sets, but water takes more time to cool down. So what happens now, this is cold, land is cold, so over here the air is also a little bit cooler. So the air and the high pressure zone is created. So cooler air sinks down, and in the sea water is warmer. So low pressure zone is created and hot air rises up. It rises up and comes here, and this air in turn goes like this. So this becomes a cycle. So this is what happens during the night time. Now next is, take ice cubes in a glass up to 3/4 of its height. Now due to the ice cubes in the glass, the air surrounding the glass cools down. As the water vapor in this air cools down, it condenses and gets transformed into water. It is this water that collects on the outer surface of the glass. The level of humidity is different in different places. Similarly, the humidity levels also change from time to time during the period of a single day. The level of humidity of air is determined by its capacity to hold water vapor. During the night or at dawn, when the temperature of air is low, its capacity to hold water vapor is less. At such times, the excess water is transformed into water droplets, and this is what we call dew. In the afternoon, when the temperature of air is high, the capacity of the air to hold the moisture also increases. Then, compared to its full capacity to hold water, the proportion of moisture in the air is less, and we feel that the air is dry. The proportion of water vapor in the air is high during the monsoons and in coastal areas. As a result, we feel the dampness or humidity. And in summers, wet clothes dry quickly, but in rains they do not. Why do you think this is so? Why is this so? Something related to humidity? Yes, because during the rains there is more water vapor in the air. It is more humid. So wet clothes take more time to dry during the rains. My dear students, this is all for now. So what all did we study today in this particular video? In this video, we discussed about natural resources, various types of natural resources, properties of air, that air has mass and weight, what is atmospheric pressure. We discussed that atmospheric pressure is same in all the directions, and we discussed effects of air on pressure. So we discussed effect of air pressure and how increased temperature affects pressure of air. So my dear students, we will continue with this chapter in the next video. This is all for now. Thank you for watching.